Hello everyone, welcome to today's session. Let's move on to the coding part and understand the code in depth. So for implementing linear regression using Python, I will be using Anaconda with a Jupyter notebook installed. So there's a Jupyter notebook and we are using Python 3.0 on it. So we are going to use a dataset consisting of head size and human brain of different people. So let's import our dataset person matplotlib inline. We are importing NumPy as NP, pandas as PD and matplotlib as from matplotlib. We are importing pyplot of that as PLT. Next, we will import our dataheadbrain.csv and store it in a database table. Let's execute the run button and see the output. But this task symbolizes that it is still executing. So there's an output. Our dataset consists of 237 rows and 4 columns. We have columns as gender, age range, head size in centimeter cube, and brain weight in grams. So there's our sample dataset. This is how it looks. It consists of all these datasets. So now that we have imported our data, as you can see, there are 237 values in the training set. So we can find a linear relationship between the head size and the brain weights. So now what we'll do? We'll collect X and Y. The X would consist of the head size values and Y would consist of the brain width values. So collecting X and Y. Let's execute the run. Now it's done. Next, we need to find the values of S1 or S0, or you can say M and C. So we'll need the mean of X and Y values. First of all, what we'll do, we'll calculate the mean of X and Y. So mean X equal NP dot mean X. So mean is a predefined function of num. Similarly, mean underscore Y equal NP dot mean of Y. So what it will return? If you will return the mean values of Y. Next we'll check the total number of values. So n equal length of X. Then we'll use the formula to calculate the values of S1 and S0 or M and C. Let's execute the run button and see what is the result. So as you can see here on the screen, we have got S1 as 0.236 and S0 as 423.412. So now that we have a coefficient. So comparing it with the equation y equal mx plus c, you can say that brain weight equal 0.236 multiplied by head size plus 423.12. So you can say that the value of m here is 0.236 and the value of c here is 423.412. So there's our linear model. Now let's plot it and see graphically. Let's execute it. So this is how our plot looks like. This model is not so bad, but we need to find out how good our model is. So in order to find it, the many methods like root mean square method, the coefficient of determination or the R-square method. So in this tutorial, I have told you about the R-square method. So let's focus on that and see how good our model is. Let's execute the R-square value. All right, here SS underscore T is the total sum of square. SS underscore R the total sum of squares of residuals, and R square as formula is 1 minus total sum of squares upon total number of squares of the residuals. Next, when you execute it, you will get the values of R square as 0.6, which is pretty very good. Now that you have implemented a simple linear regression model using least square method, let's move on and see how you will implement the model using a machine learning library called scikit-learn. So this scikit-learn is a simple machine learning library in Python. Building machine learning models are very easy using scikit-learn. So suppose there's a Python code. So using the scikit-learn libraries, your code shortens to this length like. So let's execute the run button and see you will get the same score. In the next session, we work on the logistical regression. If you have any doubt, add your doubts in the comment section. Thank you so much for watching.